Kind greetings to you all. I welcome you to Mwalimu Education Services. This video is designed for students in Senior 5 and 6 who are offering chemistry as part of their subject combinations. Kindly, if you are not falling under the mentioned categories, look for where you belong by navigating through the channel, find the material which best suits your level. Now, having explained the Octet Rule, I work out another example on dative covalence. So this is part C. We saw part A and part B. So part C is what? Part C is formation of aluminium, boron trifluoride. Formation of aluminium boron trifluoride. How does it look like? Formation of aluminium boron trifluoride. It is not aluminium. Sorry, formation of ammonia. Formation of ammonia, not aluminium. Sorry. Formation of ammonia boron trifluoride. So ammonia boron trifluoride is NH3 ammonia. You have ammonia and BFE3 like that. So that compound, ammonia boron trifluoride, it comes from ammonia, NH3. Then plus boron trifluoride. Plus boron trifluoride. What is boron trifluoride? Boron trifluoride is BFE. This is BF3. So they combine to form ammonia boron trifluoride. Ammonia boron trifluoride with the NH3 BF3 like that. Now ammonia, we have seen that ammonia has this structure NH. We have seen this at school. Yeah. Alternatively, one can also say that that ammonia has this structure. So we have nitrogen. Nitrogen with how many electrons in the outermost shell? They are, I think nitrogen is element 7. So it has 5 electrons in the outermost shell. We have seen this at school. 1, 2, 3, 4, 5. So this is N. Then for nitrogen to bond with the hydrogen, it is going to share electrons. Did I indicate that here? Let me confirm. Did I indicate it here? I think I did not. But it was obvious. So look at that structure of ammonia which we made at school. So we have hydrogen here. Maybe I change the color so that you have a clear version of it. So this is H. This is H. This is H. Look at that structure which you have in your book. We saw that H contributes and N contributes, isn't it? So here we have H contributing like that. That's what we made at school. Now look at N. I am going to use a different coloring. Look at N very well. Look at it. So what do I want to say? I want to say that I think this N here. Look at it. There is this thing here. There is also this thing here. There is also that one there, and also this one here. You know what it means? It means that let me put it here down. The colorings in green, those colorings in green, they mean that means. I don't know how I should write it. How should I write it? Okay. How should I write it? This N here you are seeing, yeah. Those colorings in green. Okay, I don't know. I don't know how I should phrase it. How should I write it? So the colorings in green, I want to say that N follows octet rule. That's what I want to say. Okay, let me put a label here. I want to say that N follows octet. N follows that N after bonding. N follows octet. N follows octet rule. Let me see whether I still have some time. Yeah, I think I have some time. N follows octet rule. N follows octet rule because, sorry. N follows octet rule because of having, because of 8 electrons, shown in green. N follows octet rule because of 8 electrons shown in green. Yeah. Huh? So you see, follows octet rule because of 8 electrons shown in green. Hence, N is electron rich. It is stable. Yeah. It is stable. Then plus boron trifluoride. Boron trifluoride, you have a metal and a non-metal. This is ionic bonding, which we have also seen at school. So boron trifluoride is B. Maybe I change this color. B with we have B with F, like that. Now, you see, on this, I put lone pairs of electrons on nitrogen. On this thing of nitrogen, they were lone pairs of electrons. But for boron trifluoride, they are not there. Don't forget the basics. I remember I mentioned this over and over again in class, that you people understand this information slowly by slowly, because where we are heading is we are going to require very strong chemistry to comprehend things. Yeah. But still, we shall be using those basics. Now you see how I am writing boron trifluoride. One can ask, why are we not having lone pairs of electrons in boron? One can ask that. Why are we not having lone pairs of electrons? Don't forget that this is why they are not there. Boron is element. Boron is element what? Is it 5? Yeah, I think, because 4 is what? 4 is beryllium. 5 is boron. So 5 is boron. Write the electronic configuration of boron. If it has atomic number 5, then it has 2 to 3. It has 2 to 3. Electronic configuration 2 to 3. So this is the outermost shell of boron. This is the outermost shell of boron. So it is B with the electrons. The electrons 1, 2, 3. That is how it looks like. So I am bonding it with, I am bonding that boron with fluorine. I'm bonding it with fluorine. Ionic bonding. You recall ionic bonding? Hope you recall. A metal transfers electrons to a non-metal. So fluorine, this is how it looks like. Maybe I use another coloring, and there are 3 fluorines. Fluorine has this. This is how it looks like. F. I also have another F here. I also have another F there. See? So F with how many electrons? With the F is element 9. It has, I think, it has 7 electrons in the outermost shell. 1, 2, 3, 4, 5, 6, 7. Also here, 1, 2, 3, 4, 5, 6, 7. Also here, 1, 2, 3, 4, 5, 6, 7, like that. So you see, that's how we represent the boron trifluoride. However, recall that to form it, a metal transfers electrons to a non-metal. A metal transfers electrons to a non-metal. So I want to say that. So you see this electron here. The metal is boron. There is those electrons in red. Look at them. They are transferred to non-metals. They are transferred to non-metals. So meaning that this is what I have. Allow me. I don't want to allow me to rewrite it in this form because I have explained. Allow me to rewrite it in this form. Explain. So we have boron transferring electrons to fluorine. Transferring electrons to fluorine. So here we have F. This is an ionic compound F. So this is B, F, F, F. So F, each F has 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Do I still have time? I have some few minutes here. So boron has, let me put this here. Sorry. Fluorine, they are 1, 2, 3, 4, 5, 6, 7. So boron contributes, see, it has 3 electrons. So we have, there is that electron there, another one there, another one there. So fundamentally, that is how boron trifluoride looks like. Now, what do you observe? Observe this B. Observe the B in the middle. You see, B has how many? I want to say that, observe this. I use a color green. I should use. Observe this. I want to say that B does not follow octet. B does not follow octet rule. Octet rule because does not follow octet rule because of 6 electrons because of 6 electrons shown in green. Because of 6 electrons shown in green. So hence B is the electron deficient. B is electron deficient. So since I have been able to convince you that N is electron rich and B is electron deficient, I want to say that N is the donor atom. N is donor atom, and B, how many minutes am I left with? Yeah, 4. I'm racing against time. And B is the acceptor atom. B is acceptor atom. So what occurs here? We shall have, now this B is acceptor atom. You see also here it has empty space. You see this thing here? This is empty space. It is empty space. That's empty space. Yeah, because of not obeying the octet rule. So that's why we have electrons transferred from here to B, like that. Or they are transferred from there, that. You see? Therefore, what do I form? I form N with H. I am bonding it with B, which carries F. Like this. And this is what you call a dative bond. Like that. Dative bond. Illustrated. So how many minutes do I have? 2 minutes. Okay. I think that is taken note of. Yeah. So if something is not following octet rule, it is electron deficient. So allow me stop here in this.